Hi, welcome back. So we're in chapter 3. You must know at the outline of combination and permutation. The concept of combination and permutation is a fundamental basic knowledge that you have to understand in order to make a good probability prediction. Let me start first of all, basic idea of a 5-digit numbers. The first question maybe you could ask, in how many ways I can choose 3 of these numbers? Another question could be, in how many ways I can arrange 3 of these numbers in different order? Or maybe you could ask a question, what is the probability of selecting 2 of these numbers? The sum could be 5, example. The permutation combination concept of understanding can help you to answer such question in a much more efficient way. Let me show you how I understand combination permutation from something that we should be familiar with by now, and that is forming a matrix, right? Question is, in how many ways I can form 3-digit numbers? And there is one condition: repetition of these numbers are not allowed. In other words, we cannot say 1, 1, and 2. One more important observation you could see here, the order is matter. In other words, this number 1, 3, 2 is quite different from this number 1, 2, 3. As later we will see another example where the order is not matter. In other words, 1, 3, 2 or 1, 2, 3 doesn't matter as long as I have chosen 3 different numbers. Anyway, so let's get back to the condition that repetition is not allowed. So we just need to take this into our consideration. I want to work by column wise. You could see that I can say 1, 1, 2 because repetition is not allowed. So what I'm going to do, it means diagonal of this matrix need to be untouchable. And since the order is important, I could say 1, 2, 3, and I could say 2, 1, 3. It is possible. So the upper side of the diagonal and the lower side of the diagonal are all accessible to me. Let's just try now to build up the space for the 1. I could write 1, 2, 3, 1, 2, 4, and 1, 2, 5. I could write also 1, 3, 2. So I'm going to get to the next point as a counter and I go back. All possible combination involving number 1 with every other numbers are in here. We met the condition. None of these numbers is repetitive. Next thing, the order was an important thing. So let's count how many possible numbers formed based on this one number. 12 different numbers I can form involving number 1. Well, I don't have to do for 2, 3, 4, and 5 because I know how many I can do for one number, so it is applicable for each and every number. Then 12 multiplied by 5, 60. So the answer is 60 different ways I can actually form 3-digit numbers where the repetition is not allowed. Another way to look at the problem, we have a 3-digit number just like so. How many ways I can choose one of these numbers? Well, 5 different ways, isn't that true? Okay, one number down, we left 4, and just be 3. So you're going to multiply all this together to the same exact result of 60. Now, also another way of looking at the problem using the official formula. In this case, we are permutating a set of numbers. I'm going to use the letter P to present permutation. So the total number that we have, 5 digits, and I would like to choose 3 out of 5. So this is the usual presentation of permutation. This is the N and this is the R. And the formula for that, you could say N factorial divided by N minus R factorial. So we have seen the visual way of looking at the problem. Let's now look at another condition. The repetition is allowed. Looks like this. This is 3 digits. You could say 1, 1, and 1. It is fine. In this case, our matrix is going to change here. So we're going to activate the diagonal just like so. We're going to start writing the space of probable numbers based on the given fact. 1 and 1. You get 1, 1 and 2, 1, 1 and 3, 1, 1 and 4, 1, 1 and 5. And then we got 1, 2 and 1. With the 4 will be 5. With the 5 will be another 5. So in total, I will be having 1, 2, 3, 4, 5 multiplication of 5. That will be 25. So I get 25 possible combination number that involve only number 1. So to get the number for all of them, multiply by 5, 125. Well, another way of looking at the problem, if you would have like these 3 digits, well, I have 5 different ways of choosing one of these numbers. For the second one, so the repetition is allowed in 5 different ways, the second number. And then again in 5 different ways, second number. That is 1, 2, 5. How about using the formula here? It is as if 5 to the power of 3. Okay, let's now change gears and try to come up with a new question. Ways that you can select 3 numbers. Selecting or forming a number of 3 digits from this list of 1, 2, 3, 4, and 5. I have chosen 2 to be selected. It means 2 of them will be not selected. So if we want to look at actually our matrix perspective, first of all, maybe we can set conditions as we did before. So for example, repetition is not allowed. Since this is the case, it means my diagonal is not going to be active anymore. The next thing we need to know, since the order is not important, so 1, 2, 3 or 3, 1, 2 or 3, 2, 1, all of which are the same because I have actually utilized the use of number 3 anyway. All of them considered to be one case. Well, if we look at the matrix here, so if I say 1, 2, 3, it is equivalent to saying 2, 1, 3. That actually the upper bound of this diagonal should be symmetric kind of a matrix. So what basically I could do here, I could say, well, I got 1, 2, 3, 1, 2, and 4, 1, 2, and 5. So what we're going to do now, we are not going back. We move only forward. So 1, 3, 4, 1, 3, 5, 1, 4, 5. All possible number happens to be with 1 is only this possible space of numbers meeting our condition. Now we cannot consider that like the previous case, just counting and say, well, it's the same with 2. So what we're going to do, actually, we have to look at 2, 3, and 4. And that's it. 4 is closed, 5 is closed. The answer is 10 different ways arranging 3-digit numbers whereby the order is not important. Another way of looking at the problem, well, since the repetition is not allowed, so I could have chosen 5, and 4, and 3, which is going to be 60. You could see from the diagonal and upper, all this have to be cancelled. And how to cancel that is by taking the factorial number of 3, or 3 factorial anyway, which is exactly identical to our answer. Another way of answering the question using the formula, 5, and I would like to choose 3 numbers. Well, considering this is my n and this is my r, which is what I'm choosing, exactly as if it's taking the n factorial divided by n minus r factorial multiplied by the r factorial, which is actually similar to what we have thought about it from this perspective here. Okay, that was all actually about combination permutation, the end of chapter 3. And now we are ready actually to move to chapter 4, and that is to discuss the world of prediction. That's exactly what we're going to do next. I will see you then.